In this video we are going to do some miscellaneous review problems. Alright, for problem number 14 we are supposed to find the measure of angle 1 right here. There are two ways you can do it, but for either one you had to remember that the relationship between the angle and the arc is that the angle is 1/2 the size of the arc. Alright, and when I'm talking about an arc right now, I'm talking about this arc right here. Okay, that green arc. Angle 1 is half the size of that green arc. So one thing I could do is subtract from 360 to figure out what this arc is. Alright, so if I do 360 minus 248, I get 112. Alright, so that means that this green arc is 112 degrees. Alright, so again the angle should be half of this. So if I do 112, well I didn't have to do that. I could just do divided by 2, which, well, I messed up. I messed up, y'all. Will you forgive me? If I divide by 2, that's going to be 56, which we could have done in our head, were we not so lazy. So that would be 56 degrees. Alright, so that was one way to do it. Subtract from 360, divide by 2. Here's the other way to do it. We could deal with this angle that's right in here first. Alright, and again this angle should be half of this arc. So if I did 248 divided by 2, that's going to give me 124. So that means this angle is 124 degrees. Now, you see that we have a straight line type situation right here. And a straight line is always a total of 180 degrees. So I could find angle 1 by subtracting from 180. Alright, 180 minus 124 degrees. Alright, again we get the 56 that we got before. So either way you want to do it. Now we're supposed to find the measure of arc CD. Alright, so this is our target right here, arc CD. Now we could find the central angle right here. We are given all other degrees in the entire circle except for this one. So we could subtract all three of these from 360. It would be slightly more efficient to realize that since the 180 is a semicircle, then this is a semicircle too on the upper side. So we could just subtract these two numbers from 180. Alright, so if we do 180 minus 96 minus 42. Okay, that's not a very good 180, but whatever. Okay, then we get 42. Alright, so that tells us that this angle right here is 42 degrees. And because this is a central angle, the angle and the arc should be the same. So arc CD should have a measure of 42 degrees. Alright, the key to this problem, we got a parallelogram. And we need to find the, what do we need to find? The measure of angle Y. Well, that's really interesting. The really interesting thing about this problem is that if we're supposed to find the measure of angle Y and not X, we don't really need this. This is like distracting. Alright, we should just scribble that out. Because the key here is that the two angles that are on the same side of a parallelogram should be supplementary. They have to add up to 180 degrees. So in other words, so I'm just going to call this Y, because it's angle Y. So 42 plus y. You know, why do we even need an equation? You get it. If they're supposed to add up to 180, then we should just do 180 minus 42. Okay, just like that. So if I do 180 minus 42, that's 138. Okay, so that is 138 degrees. Plain and simple. The x has nothing to do with it. If we were going to find x, because you know, students are so programmed to find the variable, and the only reason why I'm even doing it is so I can give partial credit to the kids who get it wrong. Whoa, technical difficulties, go away. So this angle, the whole angle is 138 degrees, as we just saw. So if you did find x somehow, what you would be doing is you'd be doing 2x equals 138. Okay, so you would divide both sides by 2. Okay, so 138 divided by 2 is 69. So if you accidentally found x, then what you found was 69. But this was unnecessary. How do you spell unnecessary? Is it 2 S's in unnecessary? That's what it was, unnecessary. However you spell it. There we go, not needed. Darn you, spell check, robbing me of my ability to spell. Okay, number 17. The measure of angle H. Oh yeah, finding the measure of angles. That was good old trig functions, tangent, sine, cosine. Do you remember this? SOHCAHTOA. Okay, yeah, SOHCAHTOA. So we are looking for this angle H, but from the perspective of angle H, this 15 is the opposite leg, and of course, no matter what angle you're talking about, 17 is the hypotenuse. Alright, so which of these three trig functions, sine, cosine, or tangent, involve the opposite and the hypotenuse? Well, that's going to be the sine function right here. Ding, ding, ding. Alright, because this part of our little acronym here, SOHCAHTOA, is to remind us that the sine, stop it, the sine of an angle is equal to the opposite leg over the hypotenuse. Alright, sine is opposite over hypotenuse. Glitch-tastic. So this is the one we want to use because that's what we have. Alright, this is too close, so I'm going to erase all this. It's too cluttered. Anyway, the point is I'm going to use the sine function. So the sine of angle H should equal opposite over hypotenuse. So that's going to be 15 over 17. Now, when you want to find the angle, you have to use inverse trig functions. So the angle will equal the inverse sine of 15 over 17. Okay, and we can just put that straight in the calculator. Alright, so we'll do inverse sine of 15 over 17. So that is 61.93. Okay, and that's it. Okay, so one angle of a right triangle is 62 degrees. what is the other acute angle? All right, in other words, not the 90 degrees, but the other acute angle. Well, the two acute angles of a right triangle are always complementary. So the easiest thing to do is to subtract from 90. So we just simply do 90 minus 62 to find the other angle. So that's 28 degrees. Alright, and that is it for problem number 18. And that's it for our little review of miscellaneous geometry problems.